Good afternoon, my students. How are you? I hope that you'll be okay and your family also okay. I hope you stay in your home. Today we need to talk about our topics that we need to complete also our topics that we finished before closing the schools. So we need to complete our topics with you, Mr. Shadi Eldib from Tabarak Private Schools.
How are you, my students? I hope you'll be fine. Welcome back again. Today we need to talk about the last topic, energy levels in atoms and line spectra. This topic is very important in final exam. This topic, it's very easy. Don't worry, it's very easy. And also you can understand it more clear. So don't worry. Today we need to talk about this energy levels. What's energy levels in atoms and also the line spectra? So let's talk about this. Firstly, we have something is known as emission spectra. What's meant by spectra? Spectra means the color or the radiation that comes out from the atom. How can this radiation comes out from the atom? As we know that around the atom we have some shells or levels of energy. And we know that if an electron is in an excited state, what's meant by excited state? As we explained that around the nucleus or around the nucleus we have more than shells or more than levels, one level of energy. All of this inside the atom. And if in each level we have electron, and these electrons are at stationary, at rest, at something is known as ground state. Ground state means it's in the lower energy. Ground state, it's the beginning energy, it's normal energy. If the atom gains energy, what happens? You will find that the electrons jump to the upper level of energy. This upper level of energy is known as excited state. So if an electron is in an excited state, it can return to a lower energy level. Why? Because it can't still in this excited state. When it does this, it loses energy. The amount of energy that lost will be equal to the difference in the energy levels it moves between. What's meant by this? When I told you the electron jump to the excited state, then it will not be in this excited state for a long time. It has to return back again to its original level. When it's returned back, it gives out energy. It lost energy. This energy that the electron lost it equals the difference between, or the difference in energy between these two levels. This energy is released as a photon, and when we said photon, it means energy and it means radiation. The energy of the photon can be worked out using the equation. What's this equation? If an electron moves from level E2 to E1, the energy of the photon can be worked out using the following. Delta E, the change in energy, equals E2 minus E1. This delta E gives us photon, energy of the photon. So it equals HF. So H, as we know that, it's a Planck constant, and F is the frequency. And we know that we can write it in another form. E or delta E equals HC over lambda. It's okay. Now, if we need to apply this in hydrogen atom, because hydrogen is the simplest atom as we know, because it has only one electron in the outer shell or outer level. So if we have hydrogen atoms, not only one atom, but also we have more than one atom, and these atoms of hydrogen gains energy. So what happened? We'll find that the electrons jump to higher levels. Look at this: n equal 1, n equal 2, 3, 4, 5, 6, 7, and so on to infinity. So it jumps to this higher or excited levels. Then what happens? It's still up? No, it has to return back. When it returns, the scientists found that some of these electrons return to level number 1 and give us radiation. This radiation, it's known as, according to the Lehman, the name of the scientist, it names Lehman series. And the second one is known as Balmer series, when the electrons return to the level number 2, and this Balmer invisible light, you will find that we have red, green, violet, indigo, blue, and so on. After that, Paschen series and bracket. Paschen returns to n equal 3 and bracket returns to n equals 4. So we have at this moment some of jumping for electron levels from higher levels to lower levels. So it's very difficult, and we have to know it, and we have to save it in your mind. This is hydrogen emission spectrum. Hydrogen emission spectrum, and it's very important for us. Then hydrogen atom, as we know, it has more than one type of spectrum. One is known as Lehman, and it's in UV, ultraviolet, and Balmer, it will be invisible light, and one in infrared like Paschen and bracket. This is energy levels for hydrogen atom. Okay. Now let's talk about one example related to the formulas that we have it in our book. Please, you have to study from your book full of information. You have to revise it and study it. Calculate the wavelength of the radiation emitted when the electron in a hydrogen atom makes a transition from the energy level at, no problem, the energy level in hydrogen atom must be in negative, no problem, according to some improvements in mathematics. No need to do this, not in our course. To the level 2.18 times 10 power negative 18 joule, and he gave you Planck's constant and also the speed of light. So he said wavelength. It's okay. As we know that delta E equals E2 minus E1. E2 minus E1. It's okay. So E2, we have it, negative 0.54 times 10 power negative 18 minus negative 2.8 times 10 power negative 18. Make it, you will find the final answer. Using the formula delta E equals HF, we said it before, and also we can write it in another form, delta E equals HC over lambda. So if we need lambda, lambda equals HC over delta E. Lambda now equals, H is a Planck constant, 6.63 or 6.6 according to the givens, 6.6 times 10 power negative 34 times C, speed of light, 3 times 10 power 8, divided by delta E, we got it from the subtraction. So the final answer will be 1.21 times 10 power negative 7 meter. If we need to convert it to nanometer, take care, because we know that if you have it in nanometer times 10 power negative 9, nano times 10 power negative 9 to convert. Okay, if we have meter, you have two ways. Number one, you can say times 10 power 9 or divided by 10 power negative 9. Both of them are the same. So you can find the value of lambda in nanometer. After that, I gave you some homeworks from your book. You can find it also in page 365, I think. So you can find some questions and the problems. I gave you one of these questions, how to find the wavelength. one of these questions, and the other one how to find a frequency. Don't forget that delta E must be in joule. So after doing subtraction, you have to check is it in joule or electron volt, and we said it before that how to convert from joule to or electron volt to joule. This is the final point in our topic today. Thank you very much. Take care. Have a nice day. We'll come back again inshallah in another video.
Thank you for your listening, and also thank you for your caring for what we explained, and thanks also for the chairman of our school, Mr. Yunus Rahbi, because he did everything related to make this process very cooperative, related to new technology in education, and how to process this technology to reach all information to the students. So thank you, and don't forget that the homework also uploaded in Moodle in the website of our school.